Hi everyone, welcome to Spring Boot course. What is Spring Boot? Spring Boot is basically a Spring module which aims to simplify the use of Spring framework for Java development and used to create a web applications. By using the Spring Boot, we can create standalone applications and it reduces lots of configuration and development and it offers embedded servers like Tomcat, JT and etc. It builds on the Spring framework, providing a simplified and faster approach to web application development. Goals of Spring Boot. First one is simplify development. Spring Boot reduces a lot of configuration and boilerplate code. Second one is auto configuration. It automatically configure components based on the dependencies and setting in application. Third one is embedded servers. It runs the application directly without needing any external deployment. Fourth one is production ready. It includes built-in support for monitoring, metrics, health checks, and externalized configuration. Fifth one is microservices architecture, streamlined development of distributed and cloud-native applications. Spring Boot versus traditional Spring framework. First one is Spring Boot. Let's talk about opinionated defaults, that is auto configuration. It provides a convention over configuration approach with opinionated defaults. Second, embedded servers, that is Tomcat, Jetty, etc. Spring Boot comes with an embedded servers. Third point is rapid development with Spring Initializer. Fourth one is provides Spring Boot Starter for quick setup standalone self-contained applications. Now let's talk about traditional Spring framework. First point is requires manual configuration. That is, it requires extensive manual configuration of beans, dependencies, and application context. Second one is external server setup required. That is, war deployment. It does not include an embedded servers must deploy applications to an external server. Third one is manual project setup and dependency management. Fourth one is need to define individual dependencies, typically integrated into existing servers. Key features of Spring Boot. Now let's first talk about auto configuration. It automatically sets up a Spring application based on the dependencies in the class path. It simplifies the setup by providing sensible defaults for the application components. It can be customized or disabled for specific use cases. We can customize the configuration by using the application.properties or application.yml files. It also reduces the need of manual configuration, enabling developers to focus on building features rather than setting up the boilerplate code. Standalone application. In Spring Boot, we can create a standalone application without needing an external server. Bundles the application with an embedded server like Tomcat, JT, or Undertow. This is one of the defining features of Spring Boot, simplifying deployment and reducing setup complexity. The application can be started with a single command, that is java-jar open bracket app.jar close bracket. Third point is opinionated defaults. Provides opinionated defaults to reduce complexity, focusing on convention over configuration. It eliminates boilerplate code and configurations meant to improve until testing and integration test procedures. Pre-configures typical application setting, example databases, web servers to streamline development. Still flexible enough to override default configuration if needed. Embedded servers. A Spring Boot comes with embedded servers such as Tomcat, Jetty, and Undertow, allowing you to deploy application directly without the need for an external containers. The server is pre-configured with sensible defaults, reducing setup and configuration overhead. It makes deployment easier for microservices and cloud native applications. Production ready features. This is one of the defining feature of Spring Boot. It includes production ready tools like Spring Boot Actuator for monitoring and managing application. Offers built-in metrics, health checks, auditing and environment information. Provides easy integration with external monitoring tools example Prometheus and Grafana. Setting up Spring Boot. First, system requirements. Java Development Kit, Java 8 or later, Maven or Gradle, Build Tool for Dependency Management, IDE, IntelliJ IDEA, Eclipse or Visual Studio Code with Spring Boot plugins, Operating System, Windows, Mac OS or Linux. Installing Spring Boot CLI. Spring Boot CLI allows you to run and test Spring Boot applications from the command line. Installation options. Windows or Mac OS. Download from the official Spring website or install using SDK-MAN. Linux. Install using Brew for Mac OS or via Packager Manager's basic command Spring version. Third, using Spring Initializer. Spring Initializer is an online tool to generate Spring Boot projects with pre-configured settings. Steps. First, go to the mentioned website. Select project type, Java version and dependencies. Third, download the generated project zip file or using Spring Initializer. Creating a project with IDE support, IDE setup, IntelliJ IDEA, built-in support for Spring Boot. Create a new project by importing from Spring Initializer. Eclipse or STS. Install the Spring Tool Suite plugin to enable Spring Boot project creation and management. VS Code. Use Spring Boot extension pack to add Spring Boot support. Importing the project. Import the downloaded project into your IDE and run the main class annotated with @Spring Boot application. Spring Boot annotations. Spring Boot annotations are a form of metadata that provides data about Spring application. Spring Boot annotations are used to simplify application development process by reducing the need for boilerplate code and explicitly defining configuration overhead, improving readability and enabling powerful features through concise declarative programming. Spring Boot annotations are present in the org.springframework.boot.auto-configure.condition packages are commonly known as the Spring Boot annotations. There is so many annotations in Spring Boot. Example, Spring Boot application, Spring Boot configuration, etc. Let's discuss about some important annotations that used widely in the programming. First, let's discuss about Spring Boot application. It is the combination of three essential annotations that is configuration, enable auto configuration and component scan. Usage marks the main class of a Spring Boot application. Following is the code. Real time example starting an e commerce application. Imagine you are running an e commerce platform. Think of the main class in the Spring Boot application, that is My App, as the master switch to start the entire application. When you run the application, it initializes all required services, configure the data connection, and set up web servers. This process starts when you execute the main method powered by Spring application.run. This process starts when you execute the main method powered by Spring application.run. Mapping the code to the example. Spring Boot application. This annotation combines add configuration that configures beans for the application. Second one is enable auto configuration. It automatically configures required components like database, server, etc. Third one is component scan. Scans the package for Spring components like services, controllers, etc. Main method is the entry point for launching the application. When executed, it initializes Spring Boot, loads the application context, that is dependency injection setup, starts the embedded server, example Tomcat, Spring application dot run, boots up the application and ensures everything is ready to handle user requests. Real life flow. This scenario is you own an e-commerce platform with a backend built using Spring Boot. The backend has services for products, orders, and payments. So, behavior, you execute the application by running myapp.main. The application starts initializing all the components: product service for managing product data, order service for handling user orders, and payment service for processing the payments. So the result is the backend is up and running, ready to serve user requests through APIs or a web interface. Example in practice: run the application Java jar e-commerce backend.jar. The backend services are initialized and you can access the application. Key steps Spring Boot handles internally, that is auto configuration, configures essential components, example database, security, and web server, dependency injection, loads all components and injects dependencies, example controller services and repository, server initialization, starts an embedded server, example Tomcat, to handle incoming requests. Practical use cases: web applications, bootstraps on entire e-commerce platform or a blogging system. Microservices starts individual services, example user service, product service in a microservices architecture. APIs launches REST APIs to handle client requests. Simplified analogy: the My App class is like turning the key in a car ignition. It starts the engine, that is Spring Boot, and ensures all systems, that is services, database, and server are ready to go. By running the main method, Spring Boot takes care of starting and wiring everything for you. Second, let's talk about configuration. The configuration annotation indicates that class contains one or more bean annotated methods that defines how to create and configure beans to be managed by the Spring container. Usage: it replaces traditional XML based Spring configuration files by allowing to define beans and dependencies in Java code. Following is the code. The code demonstrates Java-based configuration in Spring using at configuration and at bean. This is an essential concept for defining and managing beans explicitly in a Spring application. Here's a real-time example to help you understand this. Real-time example: coffee shop service configuration. Imagine you own a coffee shop and you need to set up a coffee preparation service in your system. The coffee preparation involves a coffee maker represented by My Service. You need to configure this service once and reuse it whenever it needed. The above code represents this configuration process in Spring. Mapping the code to the example. Add configuration, that is app configuration. It represents the configuration class where you define how beans like the coffee maker should be created and managed. This ensures that the coffee maker is only instantiated once and can be reused across the application. Second one is add bean, that is My Service. It declares a bean for the coffee maker service, that is My Service. Spring creates and manages this instance like a singleton by default. Third one is return value, that is My Service implementation. It represents the actual implementation of the coffee maker that brews the coffee. How it works together. Coffee shop setup. The application configuration class defines how the coffee maker is created and initialized. Dependency injection. Anywhere in your application, if you need the coffee maker, Spring provides the same instance created by app configuration. Result: the coffee shop system uses the same coffee maker instance to prepare all the coffee orders. Real life flow. The scenario is a coffee shop application requires a coffee maker service to brew coffee for customers. Behavior: the app configuration defines how to create the coffee maker instance, and the coffee maker is reused whenever coffee needs to be prepared. Practical output: if this code is a part of a larger application, here's what would happen. The service request. So when another service or controller asks for my service bean, Spring uses the configuration to provide the my service implementation instance. Singleton behavior. The same my service implementation instance is reused throughout the application. Practical use cases, shared resources, defining reusable beans like data source, REST template, or HTTP client for database connections or API calls. Custom services, configuring services like payment gateway, order processor, or email service. Third party libraries, configuring third party services. For an example, creating a bean for object mapper from Jackson. Simplified analogy. The app configuration is like a recipe book in the coffee shop. It defines how the coffee maker is created and ensures you do not have to create a new coffee maker every time. You just reuse the configured one. This approach helps manage dependencies clearly, promotes reusability, and adheres to inversion of control principle. Third one is enable auto configuration. It is the core annotation in Spring Boot that allows Spring Boot to automatically configure the Spring application context based on the dependencies present in the application class path. Uses: it often combined with Spring Boot application. Also, it can be used separately to enable auto configuration for specific modules in Spring Boot. Fourth one is component scan. The component scan annotation in Spring Boot is used to specify the base packages for Spring to scan for components, configurations, and services. It is typically used to enable scanning for classes annotated with annotations like component, service, repository, and controller. Usage: this automatically registers beans from the specified package. Following is the code. The code provided demonstrates the use of component scan in Spring. This annotation is used to automatically detect and register Spring components from specified packages. Here's a real-time example to help understand this concept. So the real-time example is online shopping platform. Imagine you are building an online shopping platform where packages for different functionalities are com.example.myapp.service, which contains services like product service or order service. Second one is com.example.myapp.repository, which contains repositories like product repository or order repository. Third one is com.example.myapp.controller, which contains controllers for handling user requests like product controller and order controller. So the goal is you want to automatically detect and register all components from the package com.example.myapp and its sub-packages without explicitly declaring each bean. How it works. At component scan, it specifies the base package where Spring should search for annotated components. Automatic detection, that is, Spring scans all sub-packages of com.example.myapp and registers classes annotated with. At service, business logic components example product service. Next one is repository, database handling components. Example is product repository. Next one comes controller, web request handlers. Example product controller. So the result is all necessary components are registered and ready for dependency injection without manual configuration. Real life scenario. First one is system components. A typical shopping system might have product service that fetches product details and product repository that connects to the database to retrieve product data, and also the product controller which handles HTTP requests for product related operations. Example showing product details. Second one is using at component scan by adding add component scan, that is base packages is equals to com.example.myapp, Spring automatically registers product service and product repository and product controller as beans. Benefits: no manual bean declaration. You do not need to use add bean for each component in the app configuration file. Spring scans and registers component automatically. Scalability: as the system grows, new services, repositories, or controllers added under the package com.example.myapp are automatically detected. Clean code. No boilerplate configuration. It only focuses on the package structure and annotation. Practical output. If the following classes exist in the com.example.myapp package, product service annotated with at service, product repository annotated with repository, product controller annotated with at controller. Spring will detect and manage these components automatically when you define add component scan, that is base packages is equal to com.example.myapp. You can then inject these components wherever needed using add auto wide. Simplified analogy. Think of add component scan as turning on a scanner that automatically detects and registers all essential parts of a system like sensor, cameras or lights based on their location in the system. This approach reduces manual work and promotes modular and clean code, especially in larger applications. There is other commonly used annotations. They are REST controller. The REST controller annotation in Spring Boot is specialized version of controller annotation. It is used to create RESTful web services and APIs in Spring Boot applications. It combines the functionality of controller and response body for APIs. Second, let's talk about auto-wide. The auto-wide annotation in Spring Boot is used for dependency injection. It allows Spring to automatically inject the required bean into a component such as class, method, or constructor. Now let's talk about service. The service annotation in Spring Boot is used to mark a class as a service layer component in the application. Now let's talk about repository. The repository annotation in Spring Boot is a specialized version of the component annotation used to indicate that a class is part of the persistence layer. It is typically applied to classes that interact with a database or any other data source such as DAO, that is data access object classes, or JPA repository. Request mapping. The request mapping annotation in Spring Boot is used to map web requests to specific handler methods or controller classes. Last one is entity. The entity annotation in Spring Boot is used to mark a class as a JPA entity, meaning it represents a table in a relational database.